before I show you any steps, let me tell you this. This system has infinitely many solutions, but you don't just say infinitely many solutions. So even though you reach to a point to find out that this system has many solutions, you still have to do a few extra steps to show the relationship between x, y, and z. All right, so let's get started. All right, so the first and second equation, so there is no y in here, right? So this is an x, this is a 3x, and I would like to get rid of the x. So what I am going to do first is I am going to multiply 3 on both sides in the first equation, and then I will subtract them. So here is how I do the writing. I will take a 3, multiply equation 1, and then subtract equation 2, and then I will just call the result a new equation 2. Okay, so when you take 3, multiply equation 1 on both sides, you have a 3x, no y, then this is a 6z. 3 times 5 is 15. And then equation 2, just subtract that, so you have 3x minus y minus z equals to 1. Perform a subtraction. What do we get? 3x minus 3x is gone. 0 minus minus y, that is a plus y. 6 minus minus 1 is 7. 15 minus 1 is 14. All right, one equation, two unknowns. We cannot solve that right now, so let's just hold on to it. And then how about equation 1 and equation 3? So if I multiply 6 on both sides and then subtract that to the equation 3, I can get rid of the x, right? So I'm going to take 6, multiply to equation 1 both sides, and then I will subtract equation 3, and then I will call that a new equation 3. Okay, so 6 times 1 is 6, 6 times 2 is 12, 6 times 5 is 30. Equation 3, just copy it over. Minus y plus 5z. Do I miss a z? That one is 12z, right? Okay, so let's fix that. So this is a 12z equals to 30, and then 5z equals to 16. Okay, perform a subtraction. 6 minus 6 is gone. 0 minus minus y is past 1. 12 minus 5 is 7. 30 minus 16 is 14. All right, so let's update the system. So let's update the system. Update the system. So equation 1, I have x plus, oh, no y in there, right? So plus 2z equals to 5. And then the new equation 2 is y plus 7z equals to 14. The new equation 3 is y plus 7z equals to 14. Equation 2 and then equation 3. Do you see that equation 2 and equation 3 are exactly the same? So what happened when you subtract equation 2 and equation 3? So when you subtract them, so when you take equation 2 minus equation 3, what happened? Equation 2 minus equation 3, what happened? You get a 0 equals to 0, right? So when you perform a subtraction, we can do it like very quick, like right now. So when you subtract them, you get a 0 equals to 0. But is 0 equals to 0? The answer is true, right? So the answer is true. So this is a sign of having infinitely many solutions. What else can you do? You can say, all right, so since equation 2 and 3 are the same, okay, so can we just treat that as one equation? Absolutely yes. So let's try. Let's do it in a different color. So we will have x plus 2z equals to 5, and then y plus 7z equals to 14, right? Can we do this? Can we do 2z equals to 5 minus x, and then divide both sides by 2, 5 minus x divided by 2, and then we plug in the z over here. All right, that works, but the substitution works, but that is not going to be helpful. So 7 multiply 5 minus x divided by 2 equals to 14. You still have one equation with 2 unknowns. So that one is impossible. So since every time you get this, you subtract 2 equations, all right? and then you have a constant equals to a constant, and then in fact they are equal. It doesn't have to be 0, 0. Sometimes it can be 2 equals to 2, 5 equals to 5, -6 equals to -6. As long as the equal is true, so this is a sign of getting many solutions. So as long as you get something equal, so let's move on to the next step. What color should I use? Let's use green. All right, so as long as you get like 0 equals to 0, and then this is true, so this is a sign of many solutions. So this is a sign of many solutions. But we are not done yet. So we are not done yet. So when you see many solutions, you have to take another step. So usually we just let z equals to a. Okay, so a is a real number, like a 5, a 6, a 2.5, whatever it is. So when z is equals to a, what happens? So the equation 1 is now x plus 2 times a constant value equals to 5, then x is equals to 5 minus 2a. So since a is a constant value, like 6, 10, 5 minus the product, then x is another constant value, right? Or another real number, I should say. Equation 2, so you have y plus 7, z is now a real number, equals to 14, then y is equals to 14 minus the product of 7 times a. So there are infinitely many solutions. I would say the two planes meet at one point. The three equations, you can say the three planes or three equations, they meet at one point, x comma y comma z. All right, so what is the relationship between x, y, and z? The relationship is when z is equals to a constant value, x is equals to 5 times 2 multiply that constant value, and then the y is 14 minus 7 times that constant value. Can you let a equals to 0? Absolutely yes. When a is equals to 0, then this x is equals to 5, y is equals to 14, z is equals to 0. When a is equals to 1, then x is equals to 3, y is equals to 7. So every time you want to find a solution, okay, you just pick some values for a. All right, so that is the end of this problem. If you like it, click the like, subscribe to my channel for more contents like this, and I will meet you all in the next video.